In this video, I'm going to show you how to measure the parallactic shift to a nearby object, the angular shift to a nearby object with respect to the distant stars, when viewed from two different locations. We'll do this first with an asteroid, imaged simultaneously from opposite ends of the Earth. We'll then do this with Venus, also imaged simultaneously from opposite ends of the Earth. And then we'll do this with the nearby star system, Alpha Centauri, imaged from opposite ends of Earth's orbit around the sun, 6 months apart. Okay, let's start with the asteroid. I'm going to share my screen. Okay, I've already loaded in 2 images of the asteroid, and in the previous video I showed you how to identify which point of light is the asteroid. And for this particular asteroid we learned it's this one right here. The first image is taken from Chile, and the second one is taken from Dark Sky Observatory in North Carolina. Now, if your instructor collected fresh data for you, your instructor will tell you which particular images you want to use. You'll go to Data Providers, Skynet, and it'll be under Group, and your instructor will have taken 2 observations, and you'll want 1 image from the first observation and 1 image from the second observation that overlap in time. And your instructor should tell you which 2 overlap in time. You'll then load them in, or if your instructor did not collect fresh data and you're using archival data, in that case, you go to the sample directory. It's under Astro 101 Lab, Lab 4 Parallax, and we have a whole bunch of asteroids. And you want to go back into the same folder that you already began this exercise with. For us in this video, it's the spring 2018 data. Previously, we went into the movie folder. This time we'll go into the Parallax folder. Here are 2 images taken by different telescopes simultaneously, or at least very close to simultaneously, within about 20 seconds of each other, and load those in. Now, I've already loaded those in, so I'm just going to go back to the workbench. And what we want to do once you load your images in, whether they're archival or whether they're fresh observations taken by your instructor on behalf of the class, you're going to want to check that they were taken almost simultaneously. So let's begin with our image that was taken from Chile. I'm going to go to the Show File Info tab, and here we see it's the Prompt 5 telescope in Chile, and this image began at 3:29:44 Greenwich Mean Time, also the same as Universal Time. Now if we go to the other, we see it was taken at excuse me, 3:29:43. Okay, so these 2 were taken within 1 second of each other, so that's great. Any angular shift that we see with the asteroid is going to be due to parallax, and not due to the motion of the asteroid between when the first image was taken and the second image. The greater the time difference, the more the angular shift can be due to just the motion of the asteroid through space with time than due to the parallactic shift. But these 2 were taken almost exactly simultaneously. Okay, great. So next we're going to need to align these 2 images to each other and stack them just like we did previously. So let's go down to the Show Aligning tab. Now if you have any files already selected, you'll want to hit the X to clear that out, and then go down to the files you want, 1 from each telescope. Get them in there. This should be set to astrometric. We're going to want to overwrite, so that should be checked. We're going to press Submit. It's processing the job, so now they have been aligned to their background stars. Next, we're going to stack them on top of each other. So again, if there's anything in here, I've gone down to the Stacker tool. If there's anything in here, clear it out with the X, and then go and add the images that we want, the same 2 images. Mode should be set to average, rejection and scaling should be set to none, just like before. And we're going to submit. Okay, it processed that job and made a new file. I believe it's this one. Okay, zoom to fit. You can see that those two images have been aligned. There's a slight rotation between the two images, as we can see here. And as we identified previously, this right here is the asteroid. So let's zoom into that. And you can see it's extended compared to the background stars. And that's because of the parallactic shift. It's at slightly different positions in the two images. Despite being imaged at the same time, it's because we viewed it from two different locations. One in the southern hemisphere, one in the northern hemisphere. Now, to measure the angular shift, we're going to have to separate this into two different points of light. So let's go up to the Display tab, and we're going to change the brightness and contrast settings. Maybe we'll try Bright Target and adjust it a little bit here so we can see them really well. Okay, so this is the same object imaged simultaneously, just from two different locations, and they've been averaged together into the stacked image. So we want to measure the distance between the center in the one image and the center in the other image. So we're going to use the ruler tool. And since they are well separated and distinct, we can use the centroiding tool. So I turned that on here. We want to keep planet centroiding off. Click in the center of one, center of the other, and the angular shift that I measure is 7.789 arc seconds. Now you will likely be doing a different asteroid, a different data set, so you'll have a different measurement. Okay, now we're going to repeat this exercise in the next two sections. In the next section, we're going to repeat it with Venus, also imaged simultaneously or almost simultaneously from two different positions on Earth. So I've gone ahead, I've aligned, and I've stacked that, and it is this image right here. Now this looks a little weird because we have this central dark spot, and that's because Venus is so incredibly bright. We used a special filter that blocks most of the light in the center, but lets the light in the outskirts through. So we have stars that we can use to align the two images. So these have already been aligned and stacked, so we see the darkened region in the one and the darkened region in the other. And here's Venus, where it's been imaged simultaneously in two different images, two different telescopes, and stacked together there. And the shift here is the parallactic shift. So we want to measure that, but since these overlap, we don't want to use centroiding. We're going to have to do it by eye. I should also point out with Venus, you don't really need to adjust the brightness and contrast. That central blocking of the light in the, from the center of the filter, that pretty much adjusts the brightness and contrast for you. Good enough for this image. So I'm going to look for the center of Venus in one and the center of Venus in this other image here. So I'll just click on the one. Since centroiding's turned off, you got to get it just perfect. And then you'll find a place around there. I'll let you do it yourself. And then lastly, we're going to repeat this exercise for Alpha Centauri. And I've already aligned and stacked those images. Again, you can see a small rotation, and we again use those special filters with the central neutral density. Now this one's different. These images were not taken simultaneously, but were taken 6 months apart, when Earth was on one side of the orbit, and then later when Earth was on the other side of the orbit. And we have the central blocking of most of the light, because Alpha Centauri is very, very bright. That lets us see it. And you can see Alpha Centauri is actually two stars. This is not the parallactic shift. It's a two-star system, Alpha Centauri A and Alpha Centauri B. Now A is a little saturated, so we're going to zoom in on B here. And they're blurred together, so we're going to go to the Display Settings tab and adjust the brightness and contrast so we can see the two distinct points of light. It's a little too much. I'm going to back it up a bit. Okay, and then we're going to use the measuring tool. And since they overlap, again, we can't use the centroiding clicks. We're going to have to do it by eye. So you kind of look up here for the center. It's not necessarily the brightest pixel or the center of the brightest pixel. Look at the whole distribution. There appears to be a circle of light centered kind of right there. And then you have this other circle of light, and you'll want to find its center. And that will give you the angular shift between these two. It should be a very small number because despite the great baseline of the entire diameter of Earth's orbit, stars are really far away. Okay. And that will give you angles for the asteroid, for Venus, for Alpha Centauri, and you can then use those angles and the baselines, the observation baselines, to calculate their distances in the rest of the lab. All right, that's it.